Landon, I thought you wanted to start.
I was gonna ask if we could go over the one of the homework problems, the number 18 about it's about minimizing the open box. The
Minimizing a function has to be cost, it has to be surface area, it has to be volume, it has to be something. What function?
volume.
Okay. So I did not write solutions for that one for yet. So you're saying that this is from 4.8, right?
Yes.
No, for 4.7. Sorry.
4.7.
My apologies. My apologies. Okay, so we are looking at, you said, problem 18. A box with a square base and open top. Square base. When I hold this book in my hand, I can't do anything else. It's just so heavy. Okay, so we have a square base and open top. X, X, and H. Must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimize the amount of material used. We are not minimizing the volume. We're minimizing the amount of material used. So that is the surface area. Good. So the surface area for such a box without the lid, so the surface area is, first of all, the base, x times x, plus 4 identical sides, because the base is a square, and we have x times h. So this is our surface area. Now there's a problem because we have x and h. No worries, because we know that the volume is area of the base times the height. From here, we will solve for the height. 32,000 over x squared. And we will plug it in here. And then now I have indeed s of x. In other words, it's a function of only one variable. So I have x squared plus 4x multiplied by 32,000 over x squared. I will gladly simplify 1x. So then s of x is x squared plus 128,000 over x. So this is our function. In order to find its max, min, whatever, what do I need to determine next? What is the procedure in finding max, min of a function? I have the function. What do I do next? How? Yes. So I have to find s prime. So s prime of x will be 2x. Please remember, this is very important, negative 128,000 over x squared. There is no need to mess with 1 over x. 1 over x prime is negative 1 over x squared. We know that from a long time ago. Okay, so then I have to continue and find the least common denominator. So this has to be multiplied by x squared. So 2x cubed minus 128,000. Fine. So I have the function is fully simplified as much as I could. Everything okay. Now what? What will be my next step? So I found the derivative. Now what?
Now we have to set that equal to 0?
Yes, or undefined. So s prime of x equals 0 or undefined. There is nothing undefined because it will be undefined at 0. But how can a box have a base that with the side that is 0? Not possible. Good. So when is a fraction 0?
When the numerator is 0.
Very good. So 2x cubed equals 128,000. And of course, I'll divide by 2. And when I take the cube root, because that's what I have to do, I get 4 from here and a 0. And this is in centimeters. Do I know that this gives a min or a max? No. No, I don't. I'm not ready. I'm not there yet. So I will put in S prime of x, as we always do, and S of x. And I study the sign. I refuse to study the sign of the denominator because it's always positive. And when I plug in 0 in the numerator, I get negative. If I plug in 100 in the numerator, I will get positive. And this is exactly what I was hoping for. If I want to determine, if they ask me to determine the minimum surface area, so this is definitely a minimum, then I will plug it in. So I will plug it in here. So I will do this quickly. So even if I'm not asked to do that, I just want to determine that. 40 squared plus 128,000 divided by 40, and I'm getting 4,800. So this is 4,800 squared centimeters because this is a surface area. It's guaranteed to be a minimum. So we determined x to be 40 centimeters, but I have to determine h because it's asking us to find the dimensions of such a box with a minimum surface area, giving this restriction. This is a restriction. We are restricted, right? Meaning the volume has to be that. So I have h here. So I have 32,000 divided by 40 squared. That's 1,600, so it's 20. So the dimensions will be the base, the side of the square is 40, and the height is 20. And these dimensions guarantee to give us the minimum possible surface area. Any questions, please? Anything? Any questions on the way? Maybe any of these steps. Is there anything that you would like to ask? Please don't be shy, anybody, everyone, please. Anyone, please?
Not from me. Kind of answered my question.
Excellent, good. Okay, next question. Anybody, everyone, please, any question, anything? Please ask any question. WebAssign, need help with anything? Yes, I'm ready.
I have one similar to one we did last time. Sorry. From WebAssign. So we did one where it was like closest to the line. But this one is the points on an ellipse that are furthest from the point.
Okay. So do you want me to share my screen? Will you tell me which problem?
I can help you. So it says 3x squared plus y squared equals 3. And furthest from the point 1, 0.
Max distance from 1, 0. So they're asking us to find the points or the point with a maximum distance from this point. Is that correct?
Yes, I believe so. It just says find the points on the ellipse in the equation that are furthest away from the point 1, 0.
Perfect.
And then it's got two separate boxes, one for the smaller
Sure.
y value and larger y value.
Perfect. First of all, we have to divide this equation both sides by 3. So this is x squared plus y squared over 3 equals 1. Question is, why am I doing this? Because I want to graph the ellipse. Okay. So let me refresh your memory. X squared divided by a squared plus y squared divided by b squared equals 1 means, assuming a is bigger than b, assumes this situation where this is negative a and this is a, and this is negative b and this is b. If a is bigger than b, if it's the other way around, then it's like this. So this is still negative a and negative b, positive b, but here a is greater than b, but here b is greater than a. Okay, so in this case, the denominator here is 1. So a is 1, but b squared equals 3, which means b equals plus or minus the square root of 3. So because this is a bigger number than 1, we're going to look at something like this. So therefore, negative 1, 1, and b is close to 2. So negative 1, 1, negative the square root of 3, and the square root of 3. And this is the ellipse. Okay. Now, where is the point 1, 0? Point 1, 0 is right here. So we want to find the points on the ellipse that have the largest distance from this point. I'm going to call it point A. So I don't know where they are, but I'm going to say somewhere here. I don't know. I don't care. I will determine them exactly. So this point, I'm going to denote it by B. And I'm going to say that point B has coordinates. I don't want to use A and B, so I'm going to use alpha and beta. Then I'm going to, so A is 1, 0. And then I'm going to draw the distance. And I'm going to say the distance A, B is, as Amanda told us last time, x2 minus x1 squared plus y2 minus y1 squared. Also, point B, alpha comma beta, is a point on the ellipse. A point on the ellipse has to verify the equation of the ellipse. In other words, when x is alpha, y must be beta. Otherwise, the point will not be on the ellipse. So the second equation I have is 3 alpha squared plus beta squared equals 3. Okay, next. The distance, which is our function, is the square root. I'm going to square this. 1 minus 2 alpha plus alpha squared plus beta squared. Our function has 2 variables. No good, not good. But I have this equation, and I'm going to solve this equation for what I need. I would keep alpha, and I will get rid of beta squared. Can anyone give us what beta squared is from here? Equals to from here?
3 minus 3. alpha squared.
Exactly. 3 minus 3 alpha squared. This will be taking care of beta squared. And now the function is a function of one variable. And that's all I need. 1 minus 2 alpha plus alpha squared and plus 3 and minus 3 alpha squared. I'm not jumping up and down. I still have to simplify it a little bit. 4. 1 plus 3 minus 2 alpha minus 2 alpha squared. I'm happy because I have the function. From this moment on, I just have to find the steps or use the steps that we always use. I'm asked to find max min. I don't care what it is. What is my next step after I created the function I needed to work with?
Differentiate.
Yes. So d prime of alpha. That's not good anymore. Okay, so 1 over 2 the square root of 4 minus 2 alpha minus 2 alpha squared times, can anyone tell us what? Yes. So we have a negative 2 and a negative 4 alpha. The inner function prime, this is 0, this is negative 2, and this is negative 4 alpha. What will be the next step after I find the derivative? So I found the step 1, I found the function, then I found the derivative. Now what? Now what? What do I do with this?
Then we set it equal to 0.
Excellent. So from here, what are the options or the option?
Well, the numerator can be 0.
So negative 2 equals 4 alpha, so alpha equals negative 1/2.
Wouldn't it be a positive 2 to move it to the other side?
But I moved the 4 alpha to the other side.
Oh, you moved the 4 instead of the 2. Okay.
It doesn't matter. You're right. I can move this, so I have then negative 4 alpha equals 2, so this is still 2 over negative 4, which will still be negative 1/2. Okay, back to our design here. So beta has alpha negative 1/2. I'm sorry, B has alpha negative 1/2. I have to find beta. No biggie. No biggie. I have alpha. I will determine beta. So let me write it here. This is page 4. So we have beta squared equals 3 minus 3 alpha squared, but this squared is 1/4. So then beta squared equals 3 minus 3/4. So 12 minus 3, right? 9/4. Correct my numbers always. Because sometimes I think of the next 10 steps and I may, no excuse. So 3 times 4 is 12. 12 minus 3 is 9. Awesome. Because beta is plus or minus 3/2. So therefore, as expected, we found the same alpha, negative 1/2, right here on this vertical, negative 1/2. And the two betas are, this one has 3/2 and the other one has negative 3/2. I'm going to write it, graph it again so it's clear. So this point is, I'm going to call it B1 now. Negative 1/2 comma 3/4. No, 3/2.
3/2.
Yes. It's right here in front of me. And the other one on the same vertical, this is B2, negative 1/2 comma negative 3/2, as expected. And I didn't show anything. Please don't forget, I jumped into conclusions. I cannot jump into conclusions. So alpha from alpha cannot be from -1 to 1. So d prime of alpha and d of alpha. So we got -1/2. So this is 0. I have to study the sign because I don't know what it gives. Maybe it gives a minimum, maybe it gives a maximum. I don't know yet. So when I plug in -1, I get positive, and on the other side, I get negative. So this is definitely the max as expected. I have to show this. And now I know that this distance is the maximum because of the sign of the derivative. If I want to determine the distance, if they ask me to find the distance, then I will have to use this formula. So then the distance, which is the maximum, is exactly the square root of 1 minus alpha. So 3/2, 9/4, plus 3/2, 9/4. Look at that. So the d maximum will be, so this is the square root of 2 9/4 times 9/4. So this will be 3/2 the square root of 2. And I have to approximate this because I'm not going to tell you that I have in my pocket 3/2 the square root of $2. So 1.5 times the square root. It's 2.12 units. And that's the distance. That's the maximum distance. Very good question. Thank you very much. It was great. Awesome. Anything else we need help with?